So in the previous video we saw Fourier series as expressed for a function that has period of 2 pi. Now let's talk about even and odd functions. You could, at the end of some videos, you will see how fun it is, but this is a very important fundamental thing that we need to understand in order to do this. We have a whenever we have a even function, so if f of x is even, we have that the defined integral from whatever it be minus L to L of f of x is equal to 2 times the defined integral from 0 to L of f of x dx. That is, here we have minus L, here we have L. So we have the integral from minus L to L would be all this. The defined integral from 0 to L is just this. But you know that because it's a even function, this is exactly the same area as this. So you can just multiply. So from where you have the point of symmetry, you take that part and you then just multiply it by 2. That is if you're integrating, from minus L to L. This would be, exactly the same if you have the function, for example, this, that is a parabola, just turn to the other side. If you are integrating from, in this case, L would be this, and this would be minus L, or actually you can put it as, let's say, here's A, so let me put it from A minus L to A plus L is the same as 2 times the integral from A to L, something like that. But if you want us for doing it easy, take it like this. And in even functions, the issue is, if we have an even function, we have that f of x is the same as f of minus x. F of 2, in this that we have x squared is f of x. This is also the same as f of minus x squared. This also would be f of minus x, sorry, it will also be x squared. If we have 2, 4, minus 2, 4, whatever. So this is our property on the even functions. On the odd functions now, let's say a odd function could be sine, for example, is the simpler odd function that I am remembering now. So we do something like this. This is a odd function. Here if we integrate from minus L to L, this is minus L, this is L. This will be the same as just 0, because this part will cancel with this part. So here we have all this. So we go from the end of this crest to the end of the other crest. So here the integral from minus L to L of f of x dx would be just 0 for the odd function. So also in a odd function we have that f of minus x is the same as minus f of x. So here, for example, we have that here we have this is 0, this could be pi, this could be negative pi, this could be pi over 2, and this negative pi over 2. So f of minus x, so f of minus pi over 2 should be equals to minus f of pi over 2. What is f of minus pi over 2? Minus pi over 2, we will have the unit cycle, so minus pi over 2 is the same as 3/2 pi, and whatever the sign of this thing is just minus 1. So minus 1 is equal to minus, now what is the sign of pi over 2? This is 1. So we have minus 1 equal minus 1, and this is the other property. And for the odd function, we will have, so this is for even functions, and for odd function we have f of minus x equals minus f of x, and we have this also on the integral part, this. So now let's see the multiplication of even functions with odd functions under this. So we will see that a even function times another even function is a even function, that a odd function times a odd function is a even function, and that a odd function times a even function would be a odd function. So for proving the first thing, a even function needs to accomplish this, the even function will accomplish this, and so this even function will accomplish this. So let's say that I began with to accomplish this to be true. I would have, that f of minus x should be equals to f of x, or f of minus x needs to be equal at the end to f of x. So here, this is my even function, and this even function I can put it as the multiplication of two even functions. Let's say psi, let's say phi of minus x and psi of minus x. So because each one of these are even functions, they follow this property, and so I can put this one as phi of x and this one as psi of x, and so this is just f of x. So you could do it from the other side, f of x, I can put it as these two even functions, but these two even functions, each one even function, each even function can be put as this, but because f of x is the multiplication of phi of x and psi of x, if now I'm putting f of minus x, that means that I need to put the minus x in each one of these. So at the end we have with this property, f of minus x is equal to f of x. So for that, a even function times a even function is a even function.